Okay, so we already defined this in class when you read the articles, but objective number 9 is I can define an estuary. On page 259, it gives you a definition, but you guys read this article from Sam, and basically an estuary, I'm just going to highlight here using my Digo account, is a partially enclosed body of water along the coast where freshwater streams meets and mixes with salt water from the ocean. Okay. We define it in class as where freshwater and saltwater meets. And so that's an incredible definition. An estuary comes in many different forms. We talked about salt marshes, tidal pools, mangrove forests. And something else I want you to write down is that they are the most productive ecosystem on Earth. Um, Incredibly important for carbon storage, biodiversity, acting as a nursery. And so we'll talk about most of those as we get through the rest of the unit. But for right now, know that it's freshwater and saltwater mixing, and it's incredibly productive. Here's another image of an estuary found online. You can see the source right here. And what I like about it is that it shows you where the freshwater starts coming from a river and then it ending in the ocean. We mentioned the word watershed in class. And I want you to look at this word brackish. I want you to find the word brackish as a diluted salt concentration. It's not completely fresh, it's not completely salt, it's a little bit lower. It might be in the 1.016 range in terms of how we're going to measure salinity. This is a resource found from Mariah, and it can be found on the pre-post right here, and Mariah's estuaries overview underneath objective number 11. And what you guys are looking at here, I like this diagram off of it because it kind of gives another overview of the estuary. Again, talking about the salinity, can be very low to very high, depending on rainwater, freshwater input, tides, all of that can fluctuate salinity, hour to hour. The estuary receives fresh water from many different sources, rivers, land drainage, creeks, and it also has tides, which we talked about before, which brings up nutrients, and it's also going to be where a lot of wastes mix as well. We'll talk about the pollution factor a little bit later in the unit. Okay, the next part of Objective 9 is I can explain why more estuaries are found on passive margins than active margins. You can turn to page 260 in your book. There's a short paragraph that describes the difference. And as you do that, and before you do that actually, I want you to make a T-chart in your notes, just like the one you see here, active versus passive. So pause this video so you can make the T-chart. Okay, now that you have the T-chart made, the first thing I want you to write down is some comparing their shelves. We're going to get more into these type of margins when we get to the abyss unit, but we're just going to have a brief overview. So if you don't know what a continental shelf is, I'll explain it later while we look at some diagrams. But an active margin has a really short and steep continental shelf versus a passive margin that's a low, shallow continental shelf. And I'd also throw the word long there too. It's very, very long. Since we're on that, I'm going to go to this diagram. You can see the source on the bottom. This is a diagram that kind of explains what we just wrote down. So if you look over here at the active margin, you're going to see the shelf is that lighter brown up here. It's very short. If you look at the angle of the slope, it's a lot steeper than the slope over here on the passive margin. And so when you're looking over here at the active margin, it gets deep really fast. It becomes the open ocean really fast. It runs into the slope incredibly quickly. You're going to have higher waves, and it's just a different type of ecosystem. It can support different types of producers. We're going to talk more about kelp forest more on an active margin. And you're going to see this more in the United States on the California coast based off of its tectonic plates. On our coast, we don't have very active plates, and so we're considered a passive margin. The shelf that you're looking at here, that light brown, is very long, has a smaller angle, and has a deeper photic zone, meaning there's a larger space where light can penetrate. And because of that, we can have long spreading ecosystems such as estuaries, coral reefs, mangrove forests, salt marshes, and such. And so that's the kind of the big difference in the shelf. One is long and very shallow, allows for more light, and the other one is very, very steep and gets deep pretty quickly. All right, going back to our T-chart, I just want to talk about two more things. I kind of mentioned them before, so I want to write them down. On the active, on the active margin, you're going to have higher waves. Surfers usually are going to go to California. Not going to see too much actual surfing on our East Coast. And on our coast, we have smaller, calmer waves. And we'll talk more about that wave action when we get to the abyss. We talk about the content of the margins a little bit more. We'll talk about why friction and different things go into making waves. But also another thing that's important is just the amount of light. Producers need light, and so if you're deeper, like in the active margin, because you have deeper water, you're gonna have a bigger producer, like a kelp forest, versus the passive, where you can have producers pretty much on rocks on the bottom because the photic zone in some areas goes down the whole way to the bottom. All right, lastly, I want to show you the difference in the shelves from a more aerial view looking at Google Earth. And so here's the United States on Google Earth. I'm just going to zoom in a little bit more. And what I want you to look at is, I'm trying to zoom in, is the difference on this coast. See that light blue? That's the shelf. That is the continental shelf. And where it becomes dark blue is actually the slope, and then you get to the open waters. So if you want to look at our coast, very long shelf. That's why we have a lot of salt marshes up here, salt marshes down here, and then they kind of blend in and become more mangrove forest. If I head over to California, you're going to see almost a non-existent shelf, very, very short, and then the slope is going to be incredibly steep. And later we'll talk about why that is perfect conditions for larger waves. But for us, it's the reason why salt marsh really can't exist. They need a lot of space and a lot of shallow waters.